Welcome back. In this video, I'm doing daily Leetcode problem, and for today, that's 885 spiral matrix 3. So we started the cell R start C start of and rows calls grid facing east. The northwest corner is at the first row and column in the grid, and the southeast corner is at the last row and column. So we are located here. We are facing east. And essentially they say this is northwest, this is southeast. Okay, we walk in a clockwise spiral shape to visit every position in the grid. Wherever you move outside the grid's boundary, we continue to walk outside and we eventually reach all positions. Okay, so we go from here to here, then clockwise again here, then here, here, and so on. I will give one cool approach for this problem. So the idea is this way of clockwise traveling. So first you go one step here, then we go again one step to the right, that's here. We are facing down, then we go again one step to the right here. And in this position we are facing west, but we can't go to the right in this position because we already visited this position. So we continue in the direction we were already going. So we go to this position. In this position we can't, so we are facing west and we can go right, that's the north. We are again here. The same thing is for this position. We can't go right because we already visited. So we move one position more up and so on. That's the idea. So we go right here, can go right here, can go right here, but we go here and can go right here and so on. So that's the approach. Now let's code it up. First we need directions. So directions will store so the first element will be our first direction, and that is increasing columns by 1. So rows the same, columns is increased by 1. Next direction is increasing rows by 1, so we go down 0. Next direction is decreasing columns by 1, so we go here. So that's 0, -1, and the last is decreasing row number, so -1, 0. We are interested in the number of positions, so numpos is equal to calls time rows. Current row is equal to start. Current column is equal to C start. Okay, we will have visited to know if we can turn to the right. So visited will be a set, and we will have output for our output. Okay, so we need to continue this clockwise traversal until we have visited all positions. So while numpos, or maybe this is more intuitive, while an output is not equal numpos. What do we do? So first we are at the start position. We need to add it to visited. So visited dot add current row, current column. Next thing, we need to update our position, and we also need parameter d to track which direction should we go. So visited at this. Now we update our current row and current column. So current row is plus. Let's also get our direction. So direction row, direction column is equal to directions of d and our current row is plus equal change in row, current column is plus equal change in column. Okay, now we also, before for this, we need to also add to our output this current position if it's valid, so if it's in this grid. So if 0 is less than or equal current row less than rows, and 0 less equal current column less calls, we need to add it to append it to output. So output.append cur rows cur columns. Okay, so first we had to visit it, each one. We check if position is valid and we add it to output. Then we update our position. Okay, and we also need to check if we should update our direction. So DRDC directions of the D plus 1 module 4. So we loop through these directions and we check if so if current row plus the difference current column plus difference, if it's not in visited, then we update our D parameters. So these plus equal these D plus 1 modulo 4. Okay, this seems solid. And in the end, we return our output. Let me check if it works. Okay, it's good. Let's submit. And yeah, it's worked. Okay, let's analyze the time and space complexity. So visited set, here we have of and for space complexity, and the output also. And for the time complexity, so we will essentially need to yeah, the time complexity is a bit weird to count, but weird to estimate, because it depends on, so if it was like a square grid, then I think it would be often squared, because we need to go through each element and we have n squared element, but here it's of rows time columns, I think. So correct me in comments if I'm wrong. So yeah, space complexity is also like of so columns times rows for all positions, and the same for the space over time, whatever I said first. Okay, I hope this made sense. Thank you for following, and see you in the next one.